Hello, ladies and gentlemen. This is Miss Bashauer in video form. Very exciting. I want you guys to treat this video as if you're taking notes in class. So therefore, your first step, write down your title of your notes. We're in Unit 6. This is our first lesson of the unit. And this unit is going to be all about solving what are called systems. Systems basically mean you have two equations with two variables, and you're basically looking for the one point, the one combination of x comma y that is a solution to both of them. Okay, you're looking for the one thing that's going to satisfy both of those equations. If you think about it graphically, like what we've been doing in Unit 5 where we were graphing, you can think about graphing both of your lines, and your solution is the one point in which those lines intersect. Now, unless you're talking about like parallel lines, or lines that are in fact the same line just on top of each other, pretty much every single situation where you have two lines, they're going to intersect in one point. And it is your job today, ladies and gentlemen, to figure out what that one point is. So before we actually start graphing, we're going to start with kind of a little mini introduction, and that's going to say what is going on in this situation here where we have a point, 2 comma 5, and we're trying to figure out if that point, 2 comma 5, actually is a solution for both of these. Anyone have any ideas how we might do that? Any ideas how we might figure out if that is in fact a solution to both of them? Well, the word that you want to write down is, in fact, substitution. Hopefully you are saying that out loud at home. Okay, substitution. All we got to do is take 2 comma 5 and substitute into both of our equations and see if it works. See if it gives a true statement. So my first equation is here, y equals 2x plus 1. I put in 2 for x, I put in 5 for y, and I follow some PEMDAS and I see that, wow, 5 is in fact equal to 4 plus 1. So that works. That's half of the battle. I got to check the other one. Okay, so I checked this one. What's going on with that one there? All right, so I write down y equals negative x plus 7. That's just my equation. And I plug in 2 for x, I plug in 5 for y. And is it a true statement? Well, yes, of course. 5 is equal to negative 2 plus 7. Okay, that is a true statement. It does work. I'm going to talk pretty quickly through these videos because what's cool about a video is you can stop, you can pause, you can write things down, you can click rewind and watch it again. So if at any point you said, wow, that was too fast, just pause and go back. So what did I actually figure out here? I figured out that this ordered pair, 2 comma 5, makes both equations true. Therefore, 2 comma 5 is a solution to the system. Why? Because it works for both of the equations. I'm going to give you guys 2 examples. I want you to pause, and I want you to do these right now, please. These examples are right here. In this system of equations, okay, again, we're getting used to the vocabulary. A system of equations has got 2 different equations. Is 4 comma 1 a solution? And in this system of equations here, is negative 1 comma 2 a solution? Give it a try. Substitute it into both. Click pause right now and come back to me when you're done. Alrighty, I assume that you are back and so I have a new slide here with, same as last slide, but now I got the answers shown for you. Okay, so the first example is yes, 4 comma 1 is a solution. It works in both of them. The second one, it is not a solution. So hopefully you got that for both of them. I didn't take the time to write it out here. But if you got questions, bring your questions to class and I'd be happy to go over them with you. Okay, so that is how to check if one particular point is a solution in a system. Basically, the idea is substitute. So now, back to graphing. I know you guys were probably so nervous that we were done with graphing, but do not be sad. Do not shed a tear. There is more graphing to be had. Okay, so we're going to do lots of graphing today, ladies and gentlemen. I know you're excited. Every point on a line is a solution to that linear equation. Okay, so if you graph a linear function, every point that is on that line we call a solution. It works, it fits, just like you were doing in the previous slide. If I substitute it in, it'll make a true statement. Since 2 lines will intersect at one point, obviously we got to stick in the word usually, if they're parallel, you can graph the lines to find where this one point is that they have in common. Okay, so let's try it. The steps here are as pretty obvious. Graph the first line, graph the second line, see where they intersect. All right, so let's graph the first one. When I graph the first one, I'm going to start at a y-intercept of -3, right? I'm going to do this in purple so it matches. And my slope is 1. So I go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, like so. And I connect my dots and I make a line. Please use a ruler, unlike mine that are kind of ugly a little bit, but please use a ruler. So now we're going to do the orange one. The orange one has a y-intercept of -1, and I'm going to go down 1 over 1 because its slope is -1. Okay, when I connect these two, when I connect all my points, again, use a ruler. Mine are kind of ugly. We can see that it's going to intersect here. And my solution is, let's see, my x value is 1, and my y value is -2. So that is the answer. Again, just to keep you guys awake out there in cyberspace, I want you to do this example here. Graph them. What's tricky about this first one is it doesn't start y equals. Make it start y equals. We learned last unit how graphing with slope-intercept form is the quickest and easiest way to graph. The second one, the orange one, looks like it's a little bit more, set to go here with being solved for y. So that one isn't as much work, but the first one you want to solve for y first. Click pause, give it a try, see what you get, and come back. All right, ladies and gentlemen, I assume that you are back. So I am ready to reveal the answer. And so here we go. Hopefully when you did this second example on your own, you have this little mini graph going on in your notes as an example. And your solution is at -2, 2. Okay, hopefully these two graphs, you're getting the same more or less picture that I am, and they should intersect at x of -2 and y of +2. Okay, if you have questions, if you're not sure why that is the way it is, come and see me. Keep going. We have a little story problem that I'm going to leave you guys basically to end these notes with, and I want you to try it out on your own. It says Ms. Pashour is saving money while Santiago is spending it. Okay, so we have these situations going on that you're going to have to write as equations. First, I have $20 right now in this moment, but I am saving $5 a week. Santiago has more money than me, but he's spending it. So you're going to write y equals, write the equations for both of our situations. And the question is, when are we going to have the same amount? When are we going to overlap? What is our point of intersection? When will that happen? Well, you got to figure out what's x. Is x time or is x money? How much money will we have? Well, is the y value time or is the y value money? All right, so hopefully you understand that time in which I'm spending is going to determine my money. And I want you to graph them. Okay, I want you to graph them. When you're done with those two guys, I want you to add a third situation. Okay, I have Yolanda. She is also saving money. She has $70 right now and saves $5 a week. When will she have the same amount as Ms. Pashour? So try and put all three of these people on the same graph and take a look at what's going to happen there. Pause, give it a try, and come back to me when you're all done. All right, ladies and gentlemen, I assume that you are back because you're done. Please give it a try. Give it a try. Don't cheat. Here has basically the answers of what's going on. The purple person is the one that's going up. So hopefully we can see that in my situation here, this has got to be Miss Pash, right? Miss Pash is in purple. I started out at $20. Okay, hopefully you have that my equation is equal to 5x plus 20. And here I am. That's my situation. Santiago is starting out with more money than I have. He's starting up here at 80. Okay, he's an orange. And while he starts out with more money, he's actually spending it. So hopefully you understood that his equation is y equals negative 10x plus 80. And eventually these two lines are going to intersect. And if you got the same thing as I did, they are going to intersect here in this point here. When is that actually happening? It looks like if this is 3, this is 4. Okay, where x is equal to 4. Okay, when will they have the same amount? Well, they're going to have the same amount after 4 weeks. How much is it? Let's change colors just for fun. Okay, how much is it? Well, that's going to be your y value here. Okay, so after 4 weeks, we'll have the same amount, and the amount that we're going to have that's the same is going to be $40. Okay, hopefully you also have Yolanda on this graph. Yolanda is also saving money. She starts at 70, so 40, 50, 60. This is going to be her starting point. And if you don't have her, go and add it right now. She starts at 70 and is also saving $5 a week. So her situation is going to look, let's see, if I go up 1, she's going to save out 5. Basically what's going to happen, and it's not super clear or clean, hopefully yours is much cleaner than mine, is that the green line and the purple line are, what do we call those, ladies and gentlemen, when they have the same slope? Parallel. Okay, these are going to be parallel. If we have the same steepness, is it possible that I'm going to ever catch up with Yolanda? Are we ever going to have the same amount? If we're never going to have the same amount, any ideas what we could call this type of situation where the lines will never intersect? They're parallel, yes, they're parallel lines. But what is my solution? If I'm never going to find a solution, what would I write? Hopefully this is something that's coming back to you that we did when we did equations. If I never have a solution, if there's never a point in which they intersect, parallel lines, when we talk about their solution, is no solution because they'll never intersect. Okay? So if you need to go back through that and look at it one more time, please feel free to, like I said, just kind of go back, pause, rewind, play. That's what's kind of fun about a video. So hopefully you have a situation that looks pretty similar to mine. Again, use a ruler so it looks nice. But that is in essence what we're talking about when we're talking about solving systems by graphing, is looking for where they intersect. If they never intersect, you're looking at no solution. Okay, your homework is here in the textbook. And this is going to be due on Wednesday. Okay, it's going to be due on Wednesday at the beginning of class. Okay, on Tuesday, we'll be having a math contest. Okay, so on Tuesday, there's no oopsie. Here's the eraser tool, isn't that fun? A math contest on Tuesday. Okay, so on Tuesday, we have our contest. See if I can spell it right. And so this assignment is going to be due on Wednesday. You're doing the notes at home tonight and the assignment on Wednesday. Shouldn't be too hard of an assignment because it's mostly a review about graphing from Unit 5. Please do contact me if you have any questions. Let me know. I'm here for you and happy to help. All right, talk to you soon. Miss Bashar is checking out. Bye-bye.